Let's go ahead and do this problem where we're finding the measurements of two different angles. And to do that, we're going to be using the angle addition postulate, which says is if you have an interior angle and breaks one of the angles into two different pieces, if you add those two pieces together, then it equals the measurement of the bigger angle. So let's go ahead and look at this statement that we were able to create from that diagram. And we're going to be doing the same thing for our angles. We're going to make a statement, which then is going to become an equation. We're going to use algebra to solve that equation. So we're given that the bigger angle is 154 degrees. We're looking for one of the interior angles, which I'm going to outline right here in red. So the angle measurements that we're given here are in terms of x, and we want to find the actual value of those angles. So we're going to use an equation so that we can find what x equals, which then is going to lead us to find the actual values of those angles. So my statement that I get here using the angle addition postulate is angle BDC plus angle ADC equals the bigger angle, which is angle BDA. Then we're going to go ahead and replace each of those parts of that equation with the measurements that were given in the diagram. So the first one that we know is angle BDC, which is 3x plus 50. And we are going to repeat the process for angle ADC. And that would give us 4x plus 20. And the bigger angle measures 154 degrees. So this whole equation will equal to 154 degrees. So we get this equation, basic algebraic equation, and we're going to go ahead and solve this. We're going to solve for x. So let's go ahead and start combining our like terms. So 3x and 4x will give you 7x. Combine the constants, which then gives you 70. And now it's just going to become a two-step equation. So we're going to use our inverse operations to solve for x. So the first operation that I'm going to do the inverse or undo is plus 70. So the inverse would be minus 70. Whatever we do to one side, we're going to do to the other side. So that leaves us with just 7x on the left side of the equation and 84 on the right side of the equation. And to cancel the 7 next to the x, we're going to divide on both sides by 7, which results in x equaling 12. Now, we're not done here because we're not looking for x. We need x to look for the angle measurement that we're missing, which is ADC. So the measurement of angle ADC, as we can see in the diagram, this should be ADC, not ADA, is 4x plus 20. But because we know what x is, now we can replace x with the value that we found earlier, which was 12. Then we're going to do some basic operations here. I'm going to multiply the 4 and the 12. That gives me 48. Add the 20, which means that the angle measurement for angle ADC is 68 degrees. And I know that I wrote ADA, but it should be ADC. Let's go ahead and repeat a similar process for this other angle. So we're looking for angle BDC. So I'm going to outline it right here in blue. And again, we're given the angle measurements for the interior angles in terms of x, which then means that we need to find x first before we can find the angle measurement that we're looking for. So let's go ahead and use our angle addition postulate to create a statement, which then is going to lead us to an equation. So angle BDC plus the measurement of angle ADC equals angle BDA. Let's go ahead and replace each of those angles with the given measurements. So for this first angle, it measures negative 4x minus 7. And for the second angle there, it measures negative 5x minus 11. So we don't know the measurement of the angle BDA. Well, we're not given the actual measurement, but we know what it is. Since it forms a right angle, that means that it measures 90 degrees. So it's important to recognize this type of angles here because most of the time they won't tell you that they measure 90 degrees. This is just information that we know because it forms a right angle. Right angles measure 90 degrees. So again, we're going to go ahead and start solving for x. Combine our like terms, then combine our constants. And lastly, we're going to use inverse operations to solve for x. So to undo subtraction, we're going to add 18 to both sides. On the left side of our equation, we're going to have negative 9x left. And on the right side, we get 108. The last inverse operation that I need to perform is division. So if I divide negative 9 on both sides, I'm going to get that x equals negative 12. But once again, we're not looking for x, we're looking for the angle measurement. So then we have to plug in our x into that angle measurement that we're looking for. So that angle measurement we're looking for is negative 4x minus 7, and then we're just going to replace x with negative 12. Two negatives equal positive, so we get positive 48 minus 7, which is 41. So the angle measurement of angle BDC would be 41 degrees. So as you guys can see, if we know how to make a statement with the angle addition postulate, the rest is just basic algebra.